because it's listed. We got data values like test scores. And also, these videos can be found in the Math 120 class list also, because most of y'all's videos for Unit 1 and Unit 2, especially y'all are following Unit 1 and Unit 2 in Math 120, so you can find all these videos. Just the discussion content of each class is different. My 8 o'clock class doesn't talk very much, so I have to usually get them to try to talk, which y'all don't have a problem talking. So I did watch that movie that she talked about, and it was good. Silver Lining Playbook. Oh, it's a good movie. It is dang old. Kitchen Fire Girl. What's her name? She's perfect in that movie. No, the character, is perfect. She is crazy, psycho, angry, and she does a real good job in bringing that out. It's a real good movie. You got to get it. Is that her name, Jennifer Lawrence?
Do you see Fury yet?
No, I'm not a World War II buff. And I do not like Mary Quid. I don't like Mary Quid. I don't have to. I won't have to watch it because everybody else will be watching.
It's really good.
All right. So we have 5 numbers. The first thing you do is you establish that n is what? All right. And it's what? Odd. So that means that the median is the exact what? Middle. All right. When n is odd, the median is the middle number. You see it. But you got to put them in order. If you don't put them in order, then you might have a good chance of getting wrong. The mean is the summation of x divided by n. The summation of x, you add all these up. Now people, nobody should have to use a calculator to add these up. You got 30 plus 60. Okay, 30 plus 60 minus 3. What's 30 plus 60? 90 minus 3. 87 plus this, 104. Somebody add them up. You should get 104. There it is, 104. Divided by 5. I did that in my other classes. I do things like that in other classes, and I'll get some students saying, where'd you get 30 and 60? People, it's called mental math. This is close to what? 30. And these 3 are close to what? 20, 20, and 20. Now, what's the difference? Well, these 2 equal out, do they not? Okay, so that's 20 and 20. So you only got a difference of 1 and 1. 2, which is 3. So 90 minus 3 is 27. It amazes me that people are in college and they do not know what I'm doing when I do 30 plus 60. And it's not your fault. Whose fault is it? Besides Bush. Whose fault is it? K through 12 and your parents. K through 12, really. But they're not supposed to teach you how to think. They're just supposed to teach you how to take what? This. Yes, ma'am.
This is another question.
It is.
Where did you
We're all going to make fun of you.
Where did you get in from? Was it given?
You count them.
Oh.
1, 2, 3,
You
4.
know question.
No, it's not.
I'm making sure.
No, it's not. It's only a dumb question to Mr. Patel asked. He can take it. I've had him in class before. He can take it. How's your sister?
Not my sister.
Yes, she is. How's she doing?
She's doing good. She actually turned her life around. Like, I mean, she has.
Quit partying?
Yeah, a lot. Or she still does, but like, she makes good money. She works in Vincent.
Did she graduate?
No, she's still a sophomore. But she has a intern like in business in downtown Columbia, law firm and stuff. So she's doing real good.
Well, that's good. Tell her I said hello. Yes, she's your sister. Some way or another, cousin. All right. So mean is the summation of x divided, so that's 104 over 5. And y'all have done this 20 million times. When have you done it? At the end of the semester. anytime you find out your grade. You've done it 20 million times, so don't say you haven't. So, mean comes out to be 21. Median is 19 because it's the middle. Where is the median? Median, what do you think of? When I say median, what's the first thing you think of? Middle of the road. Nobody ever says, oh, it says median, I think that's the middle of the road, all the way down the side. No, you think of the median, it's in the middle of the road, concrete bump. It's in the middle of the road, is what you think of, the middle of the road. Mode. Mode and most start with what? The mode. The mode is the number that shows up for what? Most. Now, you can have 2 modes, you can have 3 modes, you can have 5 modes. How do you write it down? Well, if you have 1 mode, you just write the number. In this case, it's what? 19. So you just put 19. If you have 2 modes, you need to put bimodal. And then put 19, comma, whatever the other number is. They both show up the same amount of times. If 19 shows up 2 times and 17 shows up 2 times, you need to say bimodal, 17, comma 19. Trimodal, same thing. Polymodal is anything after 3. Alright? You usually don't have to worry about that. And you say trimodal, 17, comma 19, comma 21. What if you have no mode? You put 0? No. Why? Because there are some uptight instructors that will mark it wrong when you put 0. If a little essay comment, where did you get 0? 0 is not even in the data set. Okay? They know exactly what you mean when you put 0. But some of them are uptight, and my girlfriend will tell you because they do. Alright? Always put non-applicable, none, nan, ain't got none, something, but do not put 0. That takes care of that. Range. What is the range? The highest value minus the what? Lowest value. 28 minus 17. Mid-range, this is important for your box plot, which is, we're going to show you how to do probably in the next class. I don't know where it is in your homework or where it is, but Wednesday of next week, we will review, we'll go through and look at everything that I haven't covered in chapter 5 and 6. Alright? I don't know what I've covered. I have to look at your book and see. I'm just teaching everything that's out of 120 to y'all. That way, 1, if you have 120 next semester, you'll be able to do Unit 1 and Unit 2. And 2, 90% of what's in that book or what's in the syllabus is taught in 120, so I assume it's in that book. But I got to make sure. But box plot, we will cover that Monday, or this Wednesday, sorry, this Wednesday. And Monday of next week, I will go over anything that we have done. Highest plus lowest over 2. And you need that for your box plot. Now that leaves only 2 things that we haven't covered, that we haven't done, and that is the variance and the what? Standard deviation. We're going to do those on. We're going to do all of this again on the spreadsheet. I'm just going to use the spreadsheet for what purposes? Organization. I'm not trying to force it on y'all. Like people have said that I do. So pull up your handy dandy spreadsheet. And the numbers are, let me just go ahead and do this because this really irritates me when we don't put everything in the middle. I know y'all don't have any quirks like that, but I do. Okay. So I'm going to go right here and I'm going to put X. And y'all got to help me. 17, 19, 19, 21. Oh, I suck. Hold on a minute. 17. Hit the space button instead of the down. 21. So I'm going to go over here and I'm going to put mean. median, mean, median, mode, range, mid-range, variance, and standard deviation. Now, the formula for the mean, and of course y'all could probably, y'all could probably recite it, but not correctly. Y'all would do, that's where you add up all the numbers and you divide by the numbers. Yep, that's not the formula. The math formula is mean, or x bar, or the average, is equal to the summation of x over n. So that means we've got to add all these numbers up and divide it by how many numbers there are. So a lot of people don't realize that each number is x, and if you add them all up, basically you get the summation of x, and the number of numbers, or the number of items that you have, is what? N. A lot of people don't know that. So don't feel bad. There's your x. N is equal to 5. So the mean is equal to 104 divided by what? Divided by median is the middle of the road. So there's your median. When x, or when n is odd, your median and mode are observed. Write that down. When x is odd, when n is odd, your median and mode are observed. When n is even, only your mode is observed. Your median is calculated. What's your range? Highest minus low. You need that for your box plot also. Mid-range is equal to your highest plus your what? Plus your lowest divided by now, what about your variance and your standard deviation? Well, let's erase the mean formula and let's put the standard deviation up here, or variance. The reason you want to put the variance is because you need to know the relationship between variance and standard deviation. Variance is the summation of x minus x bar, quantity squared, over n minus 1. And what is the standard deviation? The square root of that formula. The square root of the what? Variance. Now, when you get confused, always go back to your formula. What do we have to do first? Well, we'll take green marker and we'll mark it green what we need to do first. So what do we need to do first? We need to subtract x bar from each x. What is x bar? Mean. So here's the mean, right here. And we'll put in right here x bar so you don't forget. Now I have to put x bar because I don't want to have to go look for the symbol because it takes too long. Z bar. Somewhere you drink. X bar. There we go. So my next column would be X minus X bar. Now, for those people that want to learn how to use Excel and already know how to use Excel, you need to learn how to lock a number. Now, the reason you need to learn how to lock a number is, let me show you how Excel works when you copy down a formula. If you don't use the lock feature and you say 17 minus 20.8 and you hit enter, it's going to read that first one right. But when I pull down to this one, the formula is going to say 19 minus what? It's going to read down from over here on your average. It's below the 20.8. What's it going to read? 19 minus 19. And then the next one's going to read 19 minus 19. And what's the next one going to read? And 11. And then 28 minus what? 22.5. It's not only going to grab this number, but it's going to grab the number under the mean. And this number is going to grab this number. And this number is going to grab this number. And this number, but you see what I'm talking about, it's going to grab this number. So how do you keep it from doing that? Well, you go back to the beginning, right here. And when you hit that L5, let me just redo it and I'll show you. Equals 17 minus, and as soon as you hit that 20.8, you hit F4. F is in Foxtrot. Fox 4. F4. And when you hit F4, it locks that last cell. So now when you copy it down, it'll be 19 minus 20.8, 19 minus 20.8, 21 minus 21.8, and 28 minus 20.8. So for those of you learning how to do Excel and those that are remembering how to do Excel, you need to remember what it does to that. It locks 20.8. Okay? I didn't say those of you who don't want to learn or not learning Excel. I did not say that you had to learn it. Now, go back to your handy dandy formula. We've done the green part. How to do that? Sorry. There. All right, we've done X minus X bar. Now what do we need to do? Take our blue marker. We need to what? Square each term. So that means we're going to take that 3.8 and what are we going to do to it? Square it. Well, Hubert, that's a negative 3.8. Does it matter? No. Why? Because when you square something, it does away with the what? And that's why you do it. So equals this raised to the second power, and that changes everything to a positive. And what did I do just then? We're at 72.8. What did I do? I added them up. So the last thing we do is you add them up. So the first thing you do is subtract the X from X bar. Right here. Then you what? Square it. And then you what? Add it up. And that 72.8 is what? What is that? That's your, starts with an N. Numerator, Hubert. That's right, class. So I'm just going to go out here beside this guy. And I'm going to put equals 72.8 over, and then what's the N minus 1? And that's your variance. So crank that out on your calculator. I'll put it in right here. Oh, excuse me. Divided by, parentheses, this minus 1. I get 18.2. And then what I do with that 18.2? Raise it to the what power? 0.5 power, or 1/2 power. And then what I do with that information? I form a normal distribution. So I'm going to go down here and I'm going to put my mean in the middle. Okay. Equals mean in the middle. And then what I do to the right? Good job. You actually listened that day. You were the one. Equals this guy plus. You don't understand. You're supposed to ask, how do you find that each time? That's what you're supposed to do. Minus. These students that try to listen and do good, I just don't understand it. So, would a 12-year-old in this class be unusual? Yes. Would a 30-year-old in this class be unusual? Yes. Because it's outside 2 standard deviations. And that's how you find, that's how you find the mean and standard deviation. Now let's do another one and let's pick out 6 people. We're going to pick out 6 people in this classroom. It'll make y'all feel awkward. Copy. Now, what am I showing y'all how to do while I'm doing this? I'm showing you how to make another what? Spreadsheet. That's right, class. And I'm going to add somebody, or we're going to add some people. So I'm going to add one person because I want to make n is equal to 6. What I'm doing is showing y'all how to make a spreadsheet with different listed values. 5, 6, 7, 8, 9, 10, 11, and 12. Now there's some homework problems that go up to 18 or 28 or something like that. So, but most of them are going to be between 5 and 10, most of them, on the test. So this is going to be n is equal to 6. And we're going to start with Miss Black, of course. Miss Black, give me your age.
Age?
Yeah, or whatever you want to give me. 25. All right. Who's next? 21. Who's next? 24. Who's next? Come on, 18, 19-year-olds. We need some. 19. 18. One more. 18. Who was that? Okay. Mr. DeVoe, how old are you? Why do you throw your number out there, man? Huh? I'm just picking on you, Mr. DeVoe. Mr. DeVoe's in a bad mood today. Why are you in a bad mood, Mr. DeVoe? Huh? Not. That's all right, Mr. DeVoe. You don't want to talk to me? That's fine. That's I understand. All right. So there's our numbers, and I got to fill in here. So I'm just gonna copy. I'm gonna check everything. Just hold on. Yeah. All right, let's go ahead and check everything. We'll take this out. All right, so the first thing we're going to do is check our summation. This right, and our n is correct, so we're going to take this number and divide by n and that's correct. And we're going to take this guy equals C28 minus this guy. Why did it do that? Oh. And there's that number, and I copy it down just to make sure. There. And now there's our numbers. Now we got to go back and check the median. Now the median here is going to be different. Why? You got to take the two middle numbers and do what? Divide by 2. So I'm going to take those two numbers. So take equals parentheses 19 plus 21 and divide it by 2. And there's our median. Our mode, do we have, okay. I don't remember how I did that, but shouldn't have done that. I'll fix it. Okay, mode, do we have a mode? 18? 18, and I'm going to mark that red because 18 is what? What's different about 18? It's observed. 18 is observed. I don't understand what would make that big of a difference. Just review it. C31 minus L. Oh, it's not locked. See, you gotta lock it, people. But I don't understand how it can unlock. There. I think I fixed it. What's the range? Minus. Good job. And the mid-range is equal to this guy plus this guy divided by 2. All right, variance. Well, the variance is going to be equal to what? This guy divided by parentheses 6 minus what? 1, Hubert. That's right, class. And then there is standard deviation. All right. The first set of data, first set of data, we had 4.3 as a variance. Look at that data. Let's see if I can get this to where y'all can see it a little bit better. Well, you can't really. I can only move it one more there. Alright. Why is the data in the first part, why is the standard deviation 4.26? And the standard deviation in the second part is 3.06. Why is it less? I'm trying to get it where you can see all the data. There. This is 4.3 and this is 3. Why is the standard deviation less? Nope. Has nothing to do with the numbers, more numbers. The right, what's happening?
The range is less than the second one.
Okay. What else? I'm looking for y'all to see one thing. Just one thing. Just focus on these 5 numbers right here. And these 5 numbers, or these 6 numbers right here. What do you think, or what one thing makes that variance drop? That's what I heard. Huh? Mode's worthless. Good try, though.
Does it matter that you have one number and the second one the first one?
I'm trying to get y'all to see. Something. What's up? What's up with that? You're heading that way. Good. Keep going. What? Yeah, we said the range was different, but why? Why is the range different? There you go. You're getting there. The numbers in the second set. Look at these numbers. And look at these numbers. What's the biggest difference that you see? This number has a what in it? I mean, this set has a what? A 28. This number has a 25. No. No. Look at the gap between 21 and 28, and look at the gap between 24 and 25. Exactly. So what number? You got 6 numbers here. You got 5 numbers here. Which number screws with the standard deviation? 28. Why does the 28? Well, 25 is not. 25 is close to 28. Why is the 28 screwed up? Because 28 has more of what? Starts with a V. Variance than the 25. You said there's a gap between what? What did you say the gap was here? You got a variance of 7 here and a variance of what? 1 here. So that shows in your standard deviation. The standard deviation is a good what? Predictor of your variance. If you've got a small standard deviation, smaller means the less what? Variance. Larger means you have more of what? Variance. You've got to be able to look at the data. You've got to be able to look at the variance, or look at not look at the variance. What did I tell y'all? I might not have told y'all this. What is the definition of average? What is the definition of the mean? What is the definition of X bar? Because I'm going to say all of those, because if I say what is the definition of average, somebody will say it's the mean. And I say what's the definition of mean, they'll say it's the average. So I'm going to go ahead and cover that. What is the definition of the mean, the average, and the X bar, and the adding up of the numbers and dividing by n? Because you'll say that next. What's the definition of those 4 things? And that's exactly what I get out of the 120 students. People go through a whole semester of probability and statistics in high school, and they can't tell you the simple definition of what the average is. The average is the number that represents no variation. If I was to give you a bar chart or a histogram, and I have to really think about this. Let's say this bar chart looks something like this. Okay? There's my bar chart. And I asked you what the definition of the mean is. You would say the definition of the mean is what? Well, the definition of the mean, what if you was to take this guy, I hope I drew it correctly. Take this guy and chop him off right here. And then we'll take and hatch him up as X's. Yeah, I would get mad and leave too. This is disgraceful. And we chop him off and put him right here. In other words, here's your X's. Okay? So I take this guy and I chop him off right there. Why did I chop him off here? Because his level was this guy. And then I take and chop this guy off and make him hatch marks and put him in this area. And I can take my red marker and I can draw a line where? Right there, can. And that number right here represents mean. So now you can tell me what the definition of mean is. It's the number that represents no what? No variation. Nothing. In other words, it's the magic number that levels the what? Playing field. It's the number that represents no variation. Or very little. Or levels the playing field. I don't know how to spell field. I always get mixed up. Yeah. I before he accept that the blah blah blah, but I don't. So anyway, so that number right there represents no variation. So you've got the mean that represents no variation, and then you've got the standard deviation that tells you how much variation what you have in the data. So you've got to learn to read this stuff, and I guarantee you that somebody in here, well, nobody knew the definitions of the mean. But you knew how to find it on calculator. But you didn't know what it was. So you missed it. Oh well. Okay. The mean is the number that represents no variation or levels playing field. In other words, it takes these guys, I'll show it to you right quick, just right. This guy fills in for this guy, and this guy fills in for this guy. And it levels the data. So, going back to the previous page, here, our number that represents no variation is, what was our mean? 21? Somewhere around there? I can't see that number. Hold on. 21. So the number that represents no variation with this data is 21. The standard deviation is 4. So that means that we do have variation in the problem due to what? At 28. This one tells us that our standard deviation, the level playing field, is at what? 21. But our standard deviation is 3. It's a little bit less because of the variation between these two numbers is less than the variation between the 21 and the 28. You was to take out this number and put a 22 here. You do a lot with it. Watch what it does. Can you predict what it's going to do? Somebody tell me what they predict it's going to do.
That standard deviation.
Would you say it's going to go down less than 3? 22. Why wasn't it 3? The other one was 3.
Numbers or something.
Look, what's the mean now? 20, right? What's that number? 22. So your gap between your mean and your highest number is a whole lot what? Lower than the one down here. The mean down here is 20. Well, what's the number down there? 25, right? So you got a difference of 5 and a difference of what? 2. Your variation is not spread out as much. So your variance is going to be, and then your standard deviation is going to be tighter. These are the things that you've got to think of when you're doing statistics. You don't just do statistics, punch it in a calculator like any monkey or my 7-year-old and say, okay, the variance and standard deviation is this. And then when a teacher asks you, what is the standard deviation? You go, You ever felt like that before? So, what do you do if you open it up to the whole class? Now, in the last class, we had 26 people, and I didn't keep it, so but you can watch that video. We had 26 people, and it came out to be really tight data. We only had, I think there was a 34-year-old, she sat right here, and a 28-year-old sat right there. Neither one of them looked like a day over 20. Okay, but they threw, and then when I threw mine in there, we just threw it all out of place. Just made it, the standard deviation was like 106. All right, so we're going to do all of y'all. So you throw out any number you want to, but make sure if you're a woman, you can throw out any number you want to. If you're a man, no, you cannot. All right, Miss Black, you said 25, right? All right, next, you said 24 or 20, what'd you say? 24. We're going this way, huh? 21. 19, 19, 18, oops, 15, 18, 29, 20, 19, 18, 19, 18. And we're going to put those in order. And I'll go with data, then we'll percent. There you go. And we're going to call them X. And what is N? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So N is equal to 12. And let's go ahead and find our summation. That's that. And mean is equal to this number divided by that number. And median is N even or odd? Even. So that means we got to count, let's see, 5 up and 5 down, right? 5 up, 1, 2, 3, 4, 5. And there's our two numbers, which are what? I'll give y'all a hint. The average of 19 and 19 is 19. But I'm going to go ahead and put the formula in here, just in case they change. You need to put the formula in there. This number plus this number, there's always some smart L. I have to say that first part because there's always some smart L. Why don't you just put 19? Yeah, you're so smart. I got 2 degrees and I didn't even know that. Divided by 2. The reason you put it is these two numbers are not always going to be what? The same. So you put the formula in there so it will calculate it. And see, I'm thinking, okay, this is 12. So up here, I got 5 and 6. So what should you be putting between 6 and 12? 7, 8, 9, 10, 11. And that way, save it, and you'll have it for the test or for your homework. And you just punch the numbers in. Okay? Unless you just want to do it the difficult way, and that's by hand and using a calculator, because I think it's a whole lot more difficult to use a calculator, but that's just me. Okay, So now I'm going to take this little mode. Let's do the mode and all that trash. Mode is equal to, I have no idea. 18 has 3. 19 has 4. 19. Let me ask you something. Mean and the median. Oops, media. That's not right. Are they close? Yes. So that tells you that your data is what? Pretty close together, pretty tight. Range. Range is really not worth anything, but they asked for it, so equals your highest minus your what? Minus the lowest. And mid-range is equal to parentheses highest plus the lowest divided by 2. And now do the variance. Well, we got to go ahead and do x minus x bar and x minus x bar quantity squared. This minus this and F4 and copy. And then take that number and do what with it? Square it, Hubert. That's right, class. And the variance is equal to this number divided by this number minus what? Minus 1, Hubert. That's right, class. Appreciate the interaction. And then what do you do to get the standard deviation from the variance? 0.5 power, good. Now look at the standard deviation. So we went from a 4.3 to a 3.0 or 3.1 back up to a 3.5. Now why did our variance, why did the standard deviation go up? The 29. 29 kind of didn't mess us up. It just opened up the gap between that last number and the range. Whereas before, right here, what's the gap between the last number and the highest? That's why it dropped down. That's why. Now if you throw a 48 in there, I kind of throw the slop in there. Dang old 48, dang old half century. That dang old dirt. Add a 68 in there. Change the standard deviation. And the standard deviation is telling you, okay, you're reading this data, what am I telling you? You're telling me that there's a lot of variance in there. But if you take that take that 68, move it down to 26, changes the standard deviation down to below 3. Now, also look at the mean and the median. That's a good indicator. If these two numbers right here are close together, that means your data is pretty tight. If you throw a 48 back in there, are they tight? No. Throw a 68 in there. Are they tight? No. Throw a 24 or 25 back in there. That is pretty tight. Interpreting, calculating, obtaining, calculating, and interpreting. That's what statistics is. Statistics is not punching in the calculator, writing down a number, and not having any earthly clue what you just wrote down. That's not what statistics is. Aprende? All right, let's do a nerd. Let's do one out of your homework. Say again. Is class over? What time's class over?
11.
It's 10:58. It ain't over yet. Heck, gum. I'll go ahead and call the roll because y'all about to go into cardio infarction. So let me call the roll.